So today, I'm going to talk about our second mathematical constant, which, as you might guess, is e. Now yes, e is a number. Math has a tendency to take letters and turn them into numbers. And while it's not nearly as popular as pi, it does show up in math a lot. But enough of this intro. Let's get to the whiteboard. Now again, e is a mathematical constant, which means that it's irrational. Which means that, like pi, we don't have an actual value for e, just incredibly accurate approximations. The most common of these approximations is to just write out the first few digits, which are 2.71828. Now, unlike pi, where I have the first 16 digits memorized, I only have these first 6 digits memorized. It's just not as popular. But so, the most common approximation of e is just writing out the first few digits. Another approximation of e is if we take 1 plus 1 over 1 factorial, plus 1 over 2 factorial, plus 1 over 3 factorial, plus 1 over 4 factorial, and just kind of continue that on. And the more of these fractions we have, the closer we'll get to e. Now, in case you're not sure what a factorial is, it's this little exclamation point. And what that means is, when you take the factorial of a number, you take that number and multiply it by all previous integers. So what I mean by that is, say we have 3 factorial, that means we take 3 times 2 times 1. Or if we have 4 factorial, that means we take 4 times 3 times 2 times 1. And that's essentially what a factorial is. It just kind of continues this pattern for each number. Now, there is another approximation of e. And that is if we take this equation, which is 1 plus 1 over x, and this quantity to the xth power. So we take that equation and find the limit as x approaches infinity. Now, I made a video about limits, so we can click on the screen to check it out. But what this means is that as we plug in larger and larger values for x, we will get increasingly close to e. So, say we plug in 1,000 for x. When we punch that into a calculator, we get 2.717. But if we plug in 1,000,000 for x, we'll say, we get 2.718. And I'm going to continue it on. We get 2, 8, and then 0. 0, the next number after 8 is actually 1, so we have a discrepancy there. But as you can see, by plugging in 1,000,000, we have a more accurate approximation for e. And as we plug in larger and larger numbers for x, we get a more and more accurate approximation. But so, these are 3 of the approximations of e. Now, so far I've told you what e is. Now I'm going to tell you what it's used for. And one of the things it's used for is compounding interest. Now, if you're unsure what that means, I'll explain it to you. Now, say you have a bank account in it with $100. So you put $100 in your bank account, and you have a 10% interest rate. You'll get 10% interest after 1 year. So that means that after 1 year, you will gain 10% of what you put in. Or in our case, $10. So, after this year, you'll gain 10% of what you put in, which is the $10 as I mentioned. Now, at this point, after the year, you then compound your interest. And that means that you take the money you've earned from interest and add it to what you initially put in. So you now have $110. So, now for this next year, you're gaining interest on $110, not $100. So, after this next year, you will gain 10% interest of this, which is $11. And if you compound it, which means you add your interest money to your initial investment, you get $121. And so you just keep continuing this. So by compounding your interest, you're able to earn more and more money. Now, this is the general setup if you have it compounded like every year, but there's no set time as to how often you have it compound. You can have it compound every year, every month, every day, every hour, every minute, or even every second. Well, what if you want to have it compound continuously? That means that as soon as you earn interest, you immediately put it in. You don't wait any time at all. Well, that is where E comes in. So we take the initial amount of money we put in, we multiply that by E, and then we raise it to R, which is our interest rate. In this case, it was 10%, and multiply it by the amount of time that has elapsed. And that will give us how much money we have earned. So this is if you're compounding continuously, immediately adding the money you've earned to what you put in. And while this is best explained with money, it does not necessarily have to relate to money. It just relates to anything that changes continuously, such as bacteria growth. Now, possibly the most famous thing about E is that if we take E to the xth power, that is the derivative of itself. Now, I've mentioned that e to the x is its own derivative before, but now I'm going to explain why. And to explain why, I'm going to use this equation. If you are unfamiliar with this equation, this is the long way to figure out a derivative. And if you haven't heard of a derivative before, I've actually made a video specifically devoted to derivatives. So if you're unfamiliar with derivatives, I recommend you check that out before you continue on with this video. So now using this equation, we're going to plug in our e to the x as our function. So we have the limit as h approaches 0 of e to the x plus h, because we're plugging in our x plus h for our x, minus e to the x all over h. Now, a special property with exponents is that if you're adding exponents, that is the same as if you're multiplying them. What I mean by that is e to the x plus h is the same as e to the x times e to the h. That's just a property of exponents. Now, as you can see, we have an e to the x in this form, the section of the equation, and an e to the x in this section of the equation. So we can factor that e to the x out. Now, since there is no h in our e to the x, the limit as h approaches 0 does not apply to our factored out e to the x. So we can factor out the e to the x all the way to the outside of the equation. So we can now have e to the x times the limit as h approaches 0 of e to the h minus 1 over h. Now, if you take out your calculator, you don't have to, I'll just tell you this, but if you want to check it, you can take out your calculator, and plug in e to the h minus 1 over h, and put increasingly smaller values for h, you'll notice that this value approaches 1. So that means that as h gets increasingly smaller, or approaches 0, this equation approaches 1. Now, this is only the case if we have an e in there. If we were to plug in 2 there, it would not approach 1. It would approach 0.693, approximately. And so only if we have e as our base there will this equation approach 1. Now, since we do have e in there, it approaches 1. It's now going to continue on with our equation. So we have our 1, and then e to the x times that, and e to the x times 1 is just, of course, e to the x. So as you can see, after going through our derivative, our long derivative formula, we get e to the x. So that shows that the derivative of e to the x is e to the x. And because of this, e to the x shows up fairly often in calculus. But yeah, so this was my second mathematical concept video about e. And, like my pi video, I've only covered the primary aspects of e. There are several things about e that I did not get to. So, if you're curious about it, I encourage you to go online and research more about it. But, nevertheless, in a few weeks I will have my third and final mathematical concept video. But, until then, hope you enjoyed it, hope you learned something, and See ya.